Hello student. Today just 15-20 minutes I am going to give you some glimpse and some hints from gravitation, and for 11 students then onward I'll put some questions in our WhatsApp group which you have to solve. For 12 students you can use this for neat purpose. Very short content of gravitation in which we'll discuss variation of G with height, depth, latitude, only application based, and escape velocity concept. This will be the target, and I'll put questions of that. All of you will have to target. Yes. First of all, on the surface of Earth, gravitational acceleration is gme by r square, where r is radius of Earth. This is on surface of Earth. Now, for all calculation purpose, we are taking Earth as a spherical with radius r. And we know that whenever we are concerned with gravitational force act by spherical object, entire mass can be considered to be concentrated at center. That's why if I am finding gravitational acceleration, let's say at any point which is at distance r from the center of Earth, then what it will be? G is equal to gme by r square. This is G on the surface of Earth, this is at some distance r. Now this height is h, then r you can replace with r plus h. So in that case, G is equal to gme upon, yes, this r can be replaced with r plus h the whole square. This is gravitational acceleration at some height h from the surface of Earth, then I am writing this as a gh. Now this equation, if I am dividing and multiplying with re, what I am getting? gme into re square upon re square, re plus h the whole square. I have divided and multiplied with re. Now see, this part represents G on the surface of Earth. So can you see that gh is equal to g re square upon re plus h the whole square. And for h very less than re, gh is equal to g 1 minus 2h by re. Yes, either you have completed your 12th or you have completed your 11th. This is quite simple derivation, you people are knowing. But remember, these both equations represents variation of G with height. gh is equal to g re square upon re plus h whole square. gh is equal to g 1 minus 2h by re. Now concept is, this is applicable for all heights, while this formula is applicable for small height. But what is definition of small height? In that case, remember, you will use this formula when h is given in terms of re, in form of re. Like, what is g at height equal to radius of Earth? What is g at height equal to diameter of Earth? In that case, you will use this formula. Or another case, when gh is given in terms of g, like at which height g reduced to half, at which height g reduced to 1/3. Again I have to repeat, gh is equal to g re square upon re plus h whole square. This formula you will use when h is given in terms of re or gh is given in terms of g. In that case, one more ready to use formula for h is equal to how much? gh is equal to g by n. Means at which height from the surface of Earth gravitational acceleration reduced to 1 by n time. Then you will get h is equal to re root of n minus 1. Okay, at this height gravitational acceleration reduced to 1 by n time than its value on the surface of Earth. Like at which height g reduced to 1 by 4, 1/4. Then here n is 4, so it will be Re at height equal to radius of Earth. G is reducing to 1/4. Okay, look, gh is equal to g Re square upon Re plus h. What height? Re whole square. Then that is g by 4. We get the answer at height equal to radius of Earth. G reduced to 1/4. So this is formula. The height at which g reduced to 1 by n time than its value on the surface of Earth. Okay. And gh is equal to g Re square upon Re plus h. These are for when gh is given in terms of g or Re is given in terms of h. Yes. Second, gh is equal to g 1 minus 2h by Re. This is for small height. Same way for depth, g at some depth is g 1 minus d by Re. Here you don't have differentiation like for small depth and large depth, only the formula. Gd is equal to g 1 minus d by Re. And third thing, as globe of Earth is rotating, so for every point on the surface of Earth we can consider a pseudo force acting away from the axis of rotation. So rotation of Earth is also affecting g. This is called latitude position of this point. Latitude position means angle between center of Earth to given point, line joining the center of Earth and given point and equatorial line. If latitude position is lambda, then variation of g with latitude g dash is equal to g minus omega square Re cos square lambda. So variation of g with height, depth and latitude. On base of this I am going to keep you some question or going to give an assignment to you people. All 11 students, I do repeat, all 11 students, you have to have solved these questions. For 12 students, yes, it depends on your need planning, whether it is coming in planning of your preparation, then you can also attempt this question or you can follow any literature. But 11 students, use these three formula. Yes.